Okay, what I'm going to cover today is related to both your homework 5 and homework 6. After the first hour, we will spend time to handle your homework 3, right? And homework 4, if you still have some issue with that. But let me tell you that one of the topic we learned probably 2 weeks ago or maybe last week was the standard template we call a vector. So if you remember, vector is a nice way, it's an object-oriented way of handling array. I mean, the other things we learn is map, and then we have array. So I assume you know a little bit about vector. Some of you probably self-study and already access. We will actually see some examples today. But more importantly today, as you know, in this class, we're talking about the bilingual issue about object-oriented language. So one is called C++, one is called JSON. So the thing is that, well, we know the array in C++, which we call a vector. But how do we actually be able to represent that using JSON? So we can actually do dump to JSON and then doing JSON to object. So that's what we're going to do. You can imagine that this is the missing piece for you to learn how to bridge this to world. If you learn this, then essentially you can take care of everything, not just the object, not just the basic type, but now you can handle arrays. That's my instruction objective today. So I'm going to show you a piece of code. That this piece of code, let me actually call it core.h. Let me tell you what that core.h is doing. So core.h is actually, this, by the way, this is a reference. You can actually do it differently. But this is a nice piece of code for us to handle what we call object mobility. So what homework 5 is asking you to do is that if Little Red Riding Hood is moving from record 1 to record 3, actually record 2. Record 2, she actually received the wine and the cake from grandma, and now she is actually moving to the edge of the forest to meet what? Big Bad Wolf. Okay, so an object-oriented way of representing this is actually we move the object from one location to the other. So what homework 5 is trying to do is that we actually let each of the location have their own program, have their own HW5 server. So that's why I call it, if you look at my code, I call it HW5 home, HW5 forest, HW5 grandma home. Okay, so essentially I have a server which is going to hosting the object at different location. So essentially when I will use this name, execute from event number 2 or record number 2 to record number 3, essentially what we're doing is that we're moving the object of the person, which is Little Red Riding Hood, and we move the thing, which is the wine and the cake, from home to forest. So essentially, we're doing what we call object mobility. Essentially, what we're doing is moving this object. How do I actually move the object? Very simple. When you move the object, you convert that C++ object into JSON. And then you use remote procedure call to send the JSON to HW5 forest. And in HW5 forest, what I did is that I actually convert that JSON back to a person we call Little Red Riding Hood, or we convert it back. This is called transportation, right? You saw this a lot in Star Trek, right? We can do that. So essentially, you're just learning a different way of doing Star Trek, but by using the dump to JSON and JSON to object. And now, voila, you have your object. is actually in the server of HW5 Flowers. So that's actually the essence about what's going to happen in your homework assignment number 5. Well, I will upload this code to you so you can actually see how this can be done in an example way. Okay, so one of the things that's actually important, if you see what we're doing about object mobility, so it will be really, really useful for us to keep tracking where this object is and also where this object has been. So essentially, you can think about this is the tracking. You can think about Google and Facebook keep tracking you about where you are to basically help you to do a lot of useful things, maybe for their revenue. But for us, it will be good for us to actually program in a way that we know each of the objects where they have been. So that's why I actually have this code in the core.h. The first data structure is not core. The first data structure is called checkpoint. So what is a checkpoint? The checkpoint is actually very simple. The checkpoint only have 2 attributes. One is called time, one is called location. Essentially, I want to find a checkpoint, which is basically say, hey, this checkpoint means that this time at this location. Okay, this just, you can make checkpoint even more complicated. For example, some of you might want to add IP address saying that at this time, at this location, I'm using this network. You can actually add checkpoint to any kind of information that fits your application. But right now, I'm just worry about, because Little Red Riding Hood, I only need to care about location and the time. About I call it checkpoint. But let's look at what is a core. So a core is going to be the root of any, I would say, root of the class hierarchy. Means that every class is going to inherit from core. Means that this core is provide a generic data structure that's helped me to track all the checkpoint that the object has gone. So what's a core? The core has only one variable, which is a vector. A vector of what? A vector of checkpoint. So essentially, you can see that this is an array of location and the time together. So essentially, any object that's going to inherit from the core. So the core is the root of the class hierarchy. And this core basically will tell you at this time, this object at this location. So you have this checkpoint over here. So there's only one attribute called checkpoints, and then it's a vector of checkpoint. And what is a checkpoint? I declare a little bit earlier over here, location and time. And by the way, for all of them, just a tradition, I always have this 2 functions, dump to JSON and JSON to object. Yes, question. Well, vector is really the C++ way of doing array. So in C++, we don't call it array, we use vector. But you raise a good point. We might be able to use other standard template. We might be able to use a map or a queue or something to represent that. Yeah, over here, I'm just using vector. But the thing is that you're right. I'm just choose this as a one option. Yeah, good. Any other question? Okay, so I hope you understand the core. The core is essentially, let me represent an array or a vector of checkpoint, which means that I can actually, for every single object, I will be able to just simply do a dump to JSON. I will be able to see all the history about where and when this particular object has been. Okay, yes?
Sorry, when you define the vector, the checkpoint is the size of the vector, right?
It's just a data type. So the way vector works is that between this this smaller sign and the greater than sign, over there is the type of the array. That's what we declare as a template. We're saying that you are defining an array of checkpoints.
Okay.
Yeah, I mean, it's the same as say size, but it's probably have more semantic information.
Okay, so you can put any, it's just the data types.
Right, the data type. You can have array of anything, for example. Yeah. All right. So that's kind of. Oh, by the way, you raised a good question. I want to answer that. Let me actually modify this.
Oh, no.
I sometimes can do this as well, meaning that is an array of a pointer to a particular type. Okay, I can do that as well. Okay, but let me actually tell you that why sometimes I like to use a pointer is that if somehow the checkpoint, I like to have a child class. I want to have a checkpoint. I want to have a checkpoint for XYZ. And inside there, I define any kind of virtual function. If I actually define only this, I'm going to lose that subclass or child class information because I kind of convert them back to the original value. So that's why it's interesting if in this case it's okay because checkpoint is only the data type I care. I don't care about the subclass. But when you have a subclass, you have to use either reference or using a pointer in order to make sure you still be able to access to the specific information in the inheritance hierarchy. Okay, so that raised me up for remind me that this is an important point about why sometimes we choose to use reference, not just the direct object. Okay, because of the inheritance hierarchy. Okay. All right, yes, please. In this example, it's a completely different class, but it's like a record because it has the time, it has the location. It just doesn't have the objects. It doesn't have like a thing or it doesn't have a person. It's just trying to maintain a recording for location and time, and we would like to associate with that to an object. And the thing is, the reason we want to do this the way we define core is we realize when we talk about a object mobility, which by the way, you can imagine how many applications that can utilize this concept. Because think about we're moving, right? Like I'm an Android phone, I'm actually moving here and there. So this basically say the core basically allow me to record the historical perspective about where and when this object has been. So that's basically trying to do that. It's like a log, historical log for this object. And then of course when you associate this with an object, then it's interesting because when you're dealing with this object, then this data become useful for you to actually perform some tracking or whatever application. That's going to be interesting. Yeah. Any other question? Okay, so I'm actually going to finish the whole thing because this is you can imagine it's quite complicated. I'm going to finish how to use the core and the checkpoint with the rest of the class on Monday. But today I will mostly focus on, well, now this is the first time you saw we have a vector, which is an array, and we want to do dump to JSON and JSON to object. So how do I actually handle the array concept from C++ to JSON and from JSON to C++? So this is actually under the code core.cpp. Okay, so let me actually first look at the easy part. The easy part is just a checkpoint. It's very similar to what you have seen before, okay? And so the checkpoint dump to JSON is fairly straightforward. It's over here, just 2 lines, because I only have a 2 variable. One is location, one is time. So I essentially just say result.location is equal to the result of this location dump to JSON. So basically, the checkpoint is going to call the dump to JSON in checkpoint is going to call the locations dump to JSON, which is the GPS PD. And then I'm actually also going to call this time.dump to JSON, which is the location, the JV times dump to JSON. So after I've done this, and then I just actually return the result, voila, I'm done. Okay, so this is not too bad about the dump to JSON. What's new to you, I would say most of you, is the dump to JSON regarding to the core. When you have the core, because I have an array, now you think about I have a vector, and I want to actually convert this vector to a JSON array. How do I accomplish that? Let me actually tell you, this is an example. Okay, this part of the code, I'm going to try to explain this piece of code. This piece of code is essentially dump to JSON for an array. So first, I'm going to check for vector. Remember, checkpoints is a vector of checkpoint. So first thing, it will have a function called size, meaning that how many elements you have in the vector. So essentially, that's kind of nice over C array because I have a way to know exactly how many elements that's actually in that vector that I have. So, okay, as long as that this size is greater than 0, meaning that it has at least one element. So now I'm actually going to go through a loop. So let me actually look at the loop. The loop is actually quite simple. It's for I is equal to whatever. This is just like a traditional C loop. Is you have an index variable called I, and then I is smaller than the size, and then I plus plus. That's a typical loop about the vector. Okay, with that loop, then I'm actually going to the other side about this. Now I actually create another JSON value. This JSON value is called JSON checkpoint. So JSON checkpoint, you don't have to worry about what it was, but it's just an empty JSON value object that I created called JSON checkpoints. And look at what I did with this. Every time, so this is the loop, and what this loop is, I'm actually going through this vector with index I. So this part of the code essentially is giving me each of the C++ object in the checkpoints vector. It returned to me is a checkpoint object. So I'm actually getting to that. And then I'm actually calling the dump to JSON, which is the function. So once I have that, I actually load the JSON representation of that checkpoint into this variable called LJV. What is LJV? I define it here is a JSON value. Okay, so essentially, I'm using L_JV, which is a local variable JV, which is receive the JSON representation of each of the checkpoint, C++ checkpoint object. Okay, so this part is interesting about the JSON programming. Once I got that JV, you see what I did? I mean, this is kind of the flexibility about JSON programming. Is JSON, I don't know what it is. I don't know when I declare, if you look at how I declare, when I declare this, I actually just say JSON checkpoint is what? It's a JSON value. I didn't say it's an integer or it's an object or it's an array. I don't have to say anything. But then what I did, you see that I'm just directly using I. When I use the I, it's actually, this is, by the way, operator overloading in C++. This operator overloading is actually saying that, wait a minute, I'm treating that as an array. Okay, so essentially what I did, you see, I'm using the I, and then I just put the I element into LJV. This basically treats JSON underscore checkpoint as an array. It's a JSON array. By the way, you will see the data later. It's a JSON array, and then I'm actually going to put that element, that LJV into that. Yeah.
Isn't this kind of similar to how you would have like a JSON array, but instead of using, like, for example, person equals to a JSON value, you just have a number? Isn't it still just a key value pair? The key is just a number that's just happens to be in like a ascending order.
Not exactly. Not exactly. So in the way JSON array works is that it doesn't have the key value. Let me actually show you an example. So let me show each of the element in the checkpoint in the JSON. It should be looks like this. The first part is actually going to be an object that's actually follow the GPS. So it's a GPS JSON object. Okay, whatever that is, that's the result. Dump it from the dump to JSON. And then the second element is actually, sorry, it should be like this because it's an object. And then the second object is actually JV time, JSON object. Okay, this one is actually equal to LJV. LJV looks like has this format. Okay, so it's a JSON object and sorry. Sorry, I make a mistake. It should be here. It should be there. This is a key value pair. This one, it says location. And then this one, it will says, sorry, it should be time. No, this way. Did I look at this key value pair? No, this one doesn't have this. Let me actually check my syntax. Okay, here is the correct way of representing the information for each of the LJV. For each of the LJV, after we call the dump to JSON, is actually going to give us this format. You will have the key, which is location, and then this is a JSON object representation, and the time, and then JV time representation. Okay, so that's each of the LV. But Kevin, back to your question, when we actually do this, so now I'm going to go this one. I'm going to represent this, the above element. I'm going to represent this as ABC. Okay, let's call the whole thing. I will call it ABC. And when I say JSON checkpoint I to the dump to JSON, sorry, checkpoint I to the dump to LJV is actually going to create the JSON checkpoint is going to be represent looks like this. The JSON checkpoint is going to look like this. ABC 1, ABC 2, whatever ABCI. And then using bracket. Okay, that's the way JSON represent array, using the bracket, this line here. So each of the, so this is actually separated by bracket, and each of them is actually, when I say ABC1, is actually just this part. So essentially, within the JSON array, in fact, you don't have this 1 or 2 or 3 anymore. You don't have this 1 or 2 or 3 anymore. But when you actually try to do this JSON checkpoint 1, 2, 3, 4, 5, it's just append to the end of each of this. So essentially what you actually look at is just looks like this. But when you want to retrieve that, which will show you, when you want to retrieve the particular element, the way JSON works is that it will actually go to this one by one and find which number. If it's 11, it will find the 11th JSON array like this, and then retrieve it. That's how it works. Okay, yeah.
So each element in your last JSON checkpoint array, it has different TPS JSON object and a different JB time.
Right, right, exactly.
Okay, and is there a reason you use, like you have LJB over there?
Right.
Is there a reason you can't just make one line that says JSON checkpoints I equals this checkpoints I dot number JSON? Is that just a convention thing? Like if you just cut out LJB.
You can do that actually.
Okay,
You can do that. Yeah. Right. And let me try to remember. There was a code. I was in fact, if I'm going to rewrite this code, I probably would just do exactly what you said. And the reason I separate now, I remember because at that point I want to print out what's LJV. I want to do something with that. That's why I have that. Yeah. Okay. Any other question? Okay. So after we did this, after we done this, so essentially we go through the loop. And this is the way I would say a lot of the industry, this part, by the way, is convention. It's a convention, the next few line. Yes.
Whatever's on the index to like look. JSON checkpoint like 2 and then location.
Right. You can actually you can do. Oh, you're talking about. I know what you're saying. You're saying that is something looks like this: JSON I, and then location, right? Of course. Yeah. In fact, I will show you the piece of code here. You see what I did here? Let me look at you look at this. This is a JSON object is checkpoint, data, and then I actually like a 2-layer of index the key, and then I go to that array. Okay, but this is related to how I construct that array. That's why I need to have an extra, besides checkpoint, I have something extra called data. I will show you right now. Yeah, it's, I mean, to programming JSON, sometimes interesting is that in your mindset, sometimes we understand how many layers, and then you just essentially use a string to actually quickly go into that. Okay, so at this point, after this piece of code, we essentially put all the objects into the checkpoint JSON underscore checkpoint. But you see that I have two variables here. The first one we already used is called JSON checkpoint. The second one is called JSON checkpoints array. So this part I would say is not related to the correctness or syntax. This part is totally a convention that a lot of industry web design, they actually use that. Okay. The way we do it is that whenever we have an array, which is the JSON array, we usually create another layer of abstraction. One part is called data, one part is called count. So essentially, you can see what I did is that I actually look at JSON checkpoint array. The data key is the data part of the object. And the count represents the size of the array. And then I actually say this checkpoint size, how big is an array. So essentially, what we did is that, let me actually go back to this. So this is the JSON checkpoint. So now I'm going to represent what is a JSON checkpoint array looks like. So it will be, looks like this. The first one, I will actually put count first. No, let me put data first. Data, the order doesn't matter in JSON, by the way. And then over here, you will see that this is equal to this part. Let me actually just copy it. Okay, it looks like this. And then count is equal to, say, 234. Something like that. Okay, so you can see that the data is actually the real data part and the count is like this. I mean, let me give you a very practical situation that this sometimes is useful. When you're actually using Facebook or Twitter, you want to see how many followers. Guess how they represent followers. They're actually using JSON array to represent. But they need to quickly display a number saying 34 or 2 million. I mean, for example, when you got a huge post that everybody click like, you have a lot of follower, that number could be huge. And the thing is that this part of the data, if you actually at runtime and try to count how many elements you have in JSON, it's going to take forever. That's why you actually have a count. So what I did when I display on your browser or your smartphone, I would just pick that count and display that number saying that, well, how many followers that you have for that particular data structure. Okay, in fact, when this part gets big, what industry does is that they only displays about like 5 or 6 pages of content. And then they usually embed a pointer at the end that one you need to retrieve. You need to go back to the server to actually retrieve more. If you actually look at some of the content with a lot of comments, you'll notice that after you flip your phone, it will actually pause for a little bit. Why? Because they are trying to retrieve another part of the JSON from the server. And so they can, but the thing is that they actually already have this number here for you to actually be able to display very quickly. So that's how the system works, and in terms of performance. That's why industry convention will usually put the data part, which could be huge, but then we provide a count for this. Okay, so that's actually what I did here. You can see that I actually create JSON checkpoint array is equal to data. And then I actually took the count is equal to whatever size it is. And then my final result, that's actually, by the way, this is the dump to JSON. I actually say result to the checkpoints is equal to checkpoints array, which means that, let me actually show you what the result looks like. The result then will looks like this. Result, no, not result, checkpoint. And then inside here is this part. So when you look at the JSON that from this code, it will be looking like this one. And then of course with a final parenthesis. Okay, so that's the data structure. Sometimes if you know this, you know you can pretty much represent all kind of information you want to represent. It's an object array. Okay. Any question for this? So what I'm showing you this piece of code is that you can actually convert a C++ vector into a JSON representation of an array. All right, so that's the first part. I still have 5 minutes. I'm going to tell you the second part. Now, how do I convert it back? Now that's actually tricky, right? So what I have is this. which is a JSON array I received from Facebook or Google or Twitter. If I actually receive this, now I want to construct, go back to the core, or go back to the vector of checkpoint. And how should I do that? And that's the other direction we have to do. That's actually covered in the second part of the code, which is JSON to object. So let me actually tell you how to do that. It's not that difficult, but there's a few things you need to worry about. The first thing you need to check whether this object that you try to convert it back is null, whether it's an object. If it's still an object, why? Let me show you that the object should be looks like what? Should be looks like this, right? This is an object that we're supposed to do. So I need to check. The first thing, the whole thing is what? This one is an object. If it's not an object or it's null, then basically I'm not going to do anything. If I continue to do that, I will get segmentation fault. Okay, so once I actually have that, the second thing I'm actually checking, okay, I'm still actually checking this part. I'm still here at the second piece of code. Look at what I did. I'm actually checking whether you have a key value pair that's actually checkpoint is null or not. But the second line, I'm actually checking differently. I said whether the checkpoint key value pair's value is actually an array. So now it is using is array to actually check because I'm expecting it's a, how do I check is an array? They actually look at bracket. They saw the bracket, they know it's an array. Okay, so if this is done, then we're actually here. Sorry. What did I do? Okay, fine. Sorry, just give me a couple minutes to finish these things. Okay, now I'm here. Now I'm going through the loop. So now it's related to the question you asked. You see that what I did is I know the checkpoint exists. And in fact, I actually missed one thing. I should actually check whether data exists. Because I said data is what? Is a convention. It's not a required. So let me actually, I actually realized this code has a problem. Now I should do this part. Sorry. I actually realized I make two mistakes. I intentionally make the mistake so to check if you follow. All right, no, I'm just kidding. Okay. I make a mistake for this. This one is not array. This one should be still object because I have a one extra layer. And over here, I'm going to check. If data is null. And then over here, I'm actually check data is an array. Okay, now I'm happy. I actually need to check this for line because I need to not only realize I have a checkpoint, but this one you can see that this is not an array. This is still an object. So I have to check whether the data is actually exist. So not only data need to exist, but data, what's data? The data's value is array, is a bracket. Then I check checkpoint data is array. All right, so now you can see that I'm using this array like syntax. I can actually go deep into any layer I like in the JSON object. Okay, so now I can finally get to this part. So now you see that I'm actually having this is a JSON array. This data is a JSON array. I know that. If it's a JSON array, then I can use the size. Just like the way I do it with vector. The size is basically tell me how many elements I have. Alternatively, I can use count. But usually because my experience is that count does not necessarily reflect the number of elements. Unless the count is huge, I usually just use a size just to be safe. Okay, so essentially this loop is I'm actually going through this loop to actually extract each of the element in that array. That's actually the key is data. Okay, so I'm going through that. But you can see how I get each of the element. Now you can see that I use this one, LJV again. I go through checkpoint, data, and the index I. This is just a reverse. I'm actually extract that part of the JSON, which is what I got is really ABC. After I've done this, this is, where's my mouse? Okay, here. Perfect. This one is actually ABC. I actually got that ABC. So now you see that I'm actually create a dummy checkpoint LCP. I create a dummy point LCP, and then I do JSON to object of that ABC, which is a checkpoint. I actually move that over there. And now this part is a little bit tricky. Depending on what you want to do, I can just simply insert that checkpoint into the vector. Let me actually remind you what is a core.h. I can simply just basically, because what's a core.h? Core.h is a vector of checkpoint. So what I could do is just simply do this lines of code here. Look at this, what I did. I basically say this checkpoint dot push back LCP. That's the way for me to insert element into a vector using a pushback. Insert it at the end of the vector LCP. What's LCP? LCP is what's the result of this line. I do create an empty LCP, and then I basically using LCP JSON to object with this LJV, which is ABC, and then I insert, and that's it. Okay, so that part of the code is basically create and then insert to the vector. I'm done, right? Well, however, I did have a lot of things in the middle, which I want to share with you because this part is interesting, is that I want to actually check whether this particular checkpoint has already been recorded. I mean, for example, sometime I was here at the same time, at the same location, but somehow somebody want to insert another entry, which means that I have a duplicate and doesn't make any sense because I don't need two records with the same timestamp with the same location. So over here, you can see that this is the way I actually use the vector programming, the C++ vector programming. I have to create something called iterator such that I can actually be able to go through each of the elements in the C++ array and check whether they're actually the same as the one I'm trying to insert, okay? And once you've done that, then you actually have a clean list of checkpoint, which you know this represent everywhere or anytime you have been there, okay? All right, I think I'm going to stop here now. Let's take a 5 minutes break and then we go to homework 3, okay? We'll continue this on Monday.